Alright, so in this problem I have m minus n squared is equal to m squared minus n squared. So to solve this problem, I'm going to first start by rewriting m minus n squared. And I'm going to rewrite this to m minus n times m minus n. Now from here, I'm going to expand this by multiplying these two. So to multiply these two, I'm going to first start by distributing the m. M times m is m squared. M times negative n is negative mn. Now I'm going to distribute the negative n. Negative n times m is negative mn. And negative n times negative n is positive n squared. So I have this is equal to m squared minus n squared. Now, I can do a few things here. I can first start by subtracting m squared on both sides, so this way these two m squares cancel out. And now I'll be left with negative mn minus mn plus n squared is equal to negative n squared. Now negative mn minus negative mn is equal to negative 2mn. And then now if I subtract n squared on both sides, these two cancel out and I get negative 2n squared. Now from here, I can divide both sides by negative 2. So then these two negative 2's cancel out, these two negative 2's cancel out, and I'm simply left with mn is equal to n squared. Now from here, I'm going to subtract mn on both sides. So then these two cancel out, and I get n squared minus mn is equal to 0. Now the greatest common factor in n squared minus mn is n. So if I factor out n, I get n times n minus m is equal to 0. So now this gives me two equations. I get n is equal to 0, which is already a solution, and I also get n minus m is equal to 0. Now, going back to our original equation, we have m minus n squared is equal to m squared minus n squared. If n equals 0, I get m minus 0 squared is equal to m squared minus 0 squared, which turns into m squared is equal to m squared, meaning m can really equal any number. If m equals 5, then I have 5 squared is equal to 5 squared. If m equals 100, I get 100 squared is equal to 100 squared. So m can equal any number if n is 0. Now for here, I have n minus m equals 0. So if I add m on both sides, I get n is equal to m. Now, if I put this back into my regular equation, I have m minus n squared is equal to m squared minus n squared, and I'm gonna rewrite n as m because they're both equal to each other. So now I have m minus m squared is equal to m squared minus m squared. M minus m is 0, so I have 0 is equal to 0. And this means that they're both equal to 0. So, now going back, what I'm going to do is do a different method to solve this problem. So method 2 is, first let's rewrite the equation. We have m minus n squared is equal to m squared minus n squared. And now this time, I'm going to again expand m minus n squared to m minus n times m minus n. And now from here, I'm going to rewrite m squared minus n squared as m plus n times m minus n. Because if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So now, as you see, we can simply divide both sides by m minus n, cancel these two out. So now I'll be left with m minus n is equal to m plus n. Meaning, if I subtract m on both sides, I get negative n is equal to positive n. If I add n on both sides, I get 2n is equal to 0, meaning n is also equal to 0. And if n equals 0, then remember how we already tried this out, m is also equal to 0. So these are my two solutions to this equation. Alright, so in this problem, I have 3 to the power of x is equal to 80. So I want to find the value of x here. So for my solution, I first start with 3 to the power of x is equal to 80. And now I'm going to take the log on both sides. So I get log 3 to the power of x is equal to log 80. Now, we want to find a way to, we want to find the value of x, right? And to get x, it's hard to do it when it's in exponent form. So we want to find a way to bring x down to make it a real term. And to do that, there is an important property of logarithms that states that if there's something in the form log a to the power of b, I can move this exponent b to the front. So this is going to equal b times log a. So in this case, I have log 3 to the power of x, and I can move x to the front. So now I have x times log 3 is equal to log 80. Now from here, I'm going to rewrite 80 here as 8 times 10. And if I have something in the form log a times b, this is equal to log a plus log b. And this is another one of the logarithmic properties. There is also log a over b, and if I have something in this form, this is the same thing as log a minus log b. So now going back to the problem, we have log 8 times 10, and we can use this property. So we can think of 8 as a and 10 as b. So this is going to equal x log 3 is equal to log of 8 plus log of 10. Now, if you guys already didn't know, log 10 is simply equal to 1. So I get x times log 3 is equal to log 8 plus log 10. Or sorry, just 1. And now remember, we want to isolate x, so the only thing left to do is to get rid of this log 3 by dividing both sides by log 3. So then this cancel out, and I get x is equal to log 8 plus 1 over log 3. Now, log 8 is equal to 0.90309, and log 3 is equal to 0.4771. So this is going to equal 0.90309 plus 1 over 0.4771. And this is equal to 1.90309 over 0.4771. Now 1.90309 over 0.4771 is equal to 3.9889. So x is equal to 3.9889. Now, the only thing left to do is to check if my solution here is correct. So the original equation was right here, 3 to the power of x is equal to 80. And my solution is x is equal to 3.9889. So if I plug this in for x into my original equation, I get 3 to the power of 3.9889 is equal to 80. Now 3.9889 is really close to 4, right? So let's first find the value of 3 to the power of 4. 3 to the power of 4 is the same thing as 3 times 3 times 3 times 3, which is the same thing as 9 times 9, which is equal to 81. Now 3.9889 is a little less than 4, meaning we can estimate that it's going to be around 1 less than 81. So it's safe to say that 3 to the power of 3.9889 is close to the value of 80.